Sign off the launching apron and all the components are over. How a weir gets failed? What are various causes of weir? So this table summarizes everything. So there are four different causes of failure. One is piping, lift, suction, and scour. So out of these four, first two, piping and uplift, they are caused by the subsurface flow. The water which is flowing through the pore structure of the soil or under the bed, that means inside the soil, bed soil of the river, that flow is causing the failure. Uplift we have discussed in detail as of now. So piping also is something that is happening in the interior of the bed only. So to prevent this piping, we provide the inverted filter also. So, and suction and scouring, they are caused by the water which is flowing on the upper side, that is the surface flow, which is flowing above this weir. Okay. So, first two causes are of subsurface flow type, and further two causes are due to the surface flow. Okay. So, what are their effects? Due to piping, if it is initiated once, if piping failure is initiated once, if it gets started, it progresses very rapidly. Okay, and it cannot be stopped. It cannot be stopped. So once the piping failure is initiated, you see that the failure has started. The piping failure has just begun. It is very, very difficult to stop this progression of this failure. You cannot prevent the failure of the structure. Okay, so I'm not discussing much detail over here because uplift pressure and piping, both of these things are to be discussed in the seepage theory chapter. We're designing our impervious floor on the basis of these two things. Okay. So what we can do to prevent this is by providing sufficient long impervious floor. So it is related to the impervious floor with upstream and downstream sheet piles. Again, that these sheet piles along with this impervious floor together, we're designing and studying it in the next chapter. For uplift pressure, the impervious floor is lifted upwards, causing cracks. So this we have discussed today. And how to prevent it? By providing sufficiently long impervious floor. Again, sufficiently long impervious floor is good for resistance against the piping also, and it's good for resistance, or you can say effectiveness against the uplift pressure also. So here something else is added also by providing sufficiently long impervious floor, sufficient thickness at various points. So we see that impervious floor is having different thickness at different points. So sufficient thickness at various points should be provided. And downstream sheet piles are also there. So all these things, along with sufficient thickness at various points. So that also is required for resistance against pressure. So in general, so these failures can be resisted or can be prevented by designing this impervious floor properly. Okay? So that is, of course, the topic of the next chapter. In the suction, what happens is, if you just imagine the water flowing from the spillway of a dam, from top of the dam, the water is sliding. As it moves down, it slides down, its velocity keeps increasing. Okay? And all of us know, more the velocity, lesser will be the pressure. Okay? So the pressure inside that water will keep on reducing as its velocity keeps on increasing. So when the velocity increases to such a extent that the pressure is lower than the atmospheric pressure, then in that particular case, the concrete structure or the floor or the glacis or the spillway on which the water is sliding, the water will have a suction effect on that floor also, and any loose aggregate or any loose portion of the floor or the concrete surface, that will be out. Okay? So concrete surface of the impervious floor or sloping glacis is worn out because of this suction effect of this high velocity water jets. Okay, how to prevent it? Additional thickness of the floor is provided. So whatever is the design thickness, we have to provide more thickness than that, so that some peeling out of the surface can be. And it can also be provided, the safety can be provided by the concrete floor of single mass instead of masonry. If the floor is provided in the form of masonry layers, in that different layers have their different strength, their strength will not be from throughout, so different layers can be removed easily. So suction will be more effective, so that floor will be damaged very soon. So instead of providing the masonry layers, we can provide the single concrete floor as a single mass. So these are the remedies for preventing suction. Suction. The last one is scouring, and we know what is scouring. The sediment on which the structure is built, it is removed because of the scouring. And what is the effect further? It causes the settlement and cracks in the structures. You can very well understand that if the subsoil is not there, or if it has gone deeper, then the structure cannot stand in air. It will also settle down further, and settling down will be different and in different portion of the structure. So cracks may appear. So therefore called the differential settlement will be there. So cracks due to differential settlement may appear in the structure that will cause the complete failure of the structure. So upstream and downstream sheet piles should be deeper calculated scour level so that the soil below the structure is not removed out. And by providing suitable length and thickness of the launching apron. So we have discussed in the previous slides that how the launching apron functions and how it prevents the damage due to discovering. That also we have seen. So providing suitable length and thickness of the launching apron will also help against this scouring phenomenon.
Hello everyone, in this video we'll see about failure of wear on permeable foundation and accordingly how to prevent this failure. That is what we'll be seeing in this video. So what is permeable foundation? Permeable foundation means if suppose this is the soil, there is no impervious structure, so it allows the flow of water underneath the surface. That is known as permeable foundation. So if suppose this is the weir and there is head of water on the upstream, which I am denoting by U bar S, and there is downstream. So this weir can fail due to two reasons. One is subsurface flow and other is surface flow. So what is subsurface flow? Subsurface flow is the flow of water underneath the ground surface. So what happens is there is a differential head. As you can see, head on the upstream is large because weir blocks the water, because of which there is head on the upstream, and downstream there is not much head when the water does not flow through the weir when the gate is open. So because of the difference in head, what happens is there is flow of water underneath the ground surface. As you can see in the 3D image also, there is flow of water underneath the ground surface. It's known as seepage, and that is subsurface flow. So this failure of weir can happen due to subsurface flow also, and also because of surface flow. So when water flows over the weir, there is hydraulic jump occurs, which acts in the upward direction, which tends to break away the foundation, and also scouring of particles take place. So failure can happen due to surface flow also. Now let us see the failure which happens due to subsurface flow. So the first one is uplift failure. So what is this uplift failure? So as you can see, there is a head of water on the upstream. This head of water on the upstream, if suppose these are the soil particles, and if you insert a piezometer here, you will find that the water rises up to the head of water. So this head of water, it applies force on these particles and tends to force the particle apart, that is break away from each other. So because of which there is a pressure developing. So the water which is inside this pores of soil, pressure develops inside this pores. So this pore water pressure which happens because of this head of water, it exerts uplift, and it is uplift because as it tends to force the particle apart, the contact force reduces between the particles. So because of which the soil strength reduces, which can be taken as it is acting upward. So this pressure which develops as the water is inside the pores is known as pore water pressure. So this pore water pressure contributes to the uplift. So this uplift can be prevented by the floor weight. If suppose this is the weir and you provide some flooring here with concrete or something. So the weight of concrete will act downward and this is the uplift. So if this weight of concrete can balance this uplift, then there is no problem. And you know the head is maximum at the upstream and at the downstream head is less. And also because of seepage, the uplift pressure keeps on decreasing. When there is seepage, water flows from one upstream to downstream. When water flows from upstream to downstream, what happens is this head keeps on reducing. The head of water at upstream and this is the head of water downstream. It can be assumed to drop constantly as water seeps through. So the pressure of water held by the pores is maximum and it keeps on decreasing. So up will be maximum at the upstream. So if this is the uplift pressure, if it can be drawn like this. So the uplift pressure is maximum at the upstream, very minimum at the downstream depending on the head of water. So when there is no flow, that is the most dangerous condition. Like when the gates are closed, there is maximum water on upstream and there is very minimum water on downstream. So this is the dangerous condition for which the uplift failure is designed. And also as you see from this image, only on the upstream side there is uplift pressure and on the downstream side it is very less. So it is how to prevent this uplift? So as you know, as you saw, when water seeps through, the head of water keeps on decreasing. So when you provide this seepage to go vertically, if you provide some sort of pile arrangement here, so what happens is the water seeps through like this. They cannot go directly. So you allow the water to seep all the way along. So when depending on the length of this pile, a lot of head is lost in this. If head of water is reduced, automatically pore water pressure is reduced, because of which there is less uplift. And also you should provide sufficient floor thickness to act downward to balance the uplift. The next interesting part is known as piping or undermining failure. So as we saw in the previous slides, so water seeps through from upstream to downstream. So when the water seeps, what it does is it exerts some drag force on the soil. So what happens is, if this is the soil particle, force acts tangentially towards it. So there is a upward component of force in the downstream. Here it is acting this way. But if you go towards the downstream and near the edge set, there is a upward component of force. Let us call this F1. And this soil is submerged. So there is a submerged weight of soil. So when F1, this seepage force is greater than the submerged weight of soil, what happens is the effective stress is 0. So it creates some sort of quicksand condition and the soil is washed away. So that is known as dislodging of soil. So if the soil is washed away here, then the next particle gets affected. Slowly it keeps on getting washed away and there is a hole. Hole slowly propagates from downstream to upstream in backward direction. So this formation of connected voids, that is, it keeps on forming voids which may go into a hollow kind of structure, that is known as pipe. So that is why it is known as piping failure. So if there is a hollow part, obviously the structure will try to subside into this hollow part, and because of which it fails. So that is known as piping failure. So how to prevent this piping failure? One is you can increase the seepage path. So at the exit there is less gradient. So that can be done with the help of downstream cutoff piles. So it has to go through. And also what you can do is you can provide something called inverted filter. So at the downstream, if you provide inverted filter, it is like you provide some drainage for the seepage water to escape, so that it doesn't cause the soil particles to dislodge. So that is one way of preventing piping. So the main idea is to increase the seepage path length.